Okay, recording has started. So if you can turn to page 20, we're going to do a second practice one, and it might be useful. I would rip out the page maybe that's got the instructions. It's up to you. I'm going to be honest, this one doesn't have to come in because I know we've skipped a bunch of pages already. So if that makes your life easier, cool. All right, so I'm going to do this in the order I like doing them. Put that over there. And I like feeling smart. So the first thing I look at is my inequality sign. And that is a less than or equal to. What kind, Rachel, do you know what kind of line I'm going to draw with that? It's either a dotted line or a solid line. If you don't know, guess. Harmony, how about you?
Solid line?
Yeah. So remember, I can say, ladies, anytime there's the little line underneath the equal to part, that means you're going to draw a solid line. In other words, ouch. Draw it like you always do. Good morning, Jose.
Morning.
Oh, dang my computer. Let's try this. Some of you suddenly appeared. I'm not being rude. I haven't been ignoring you. Look at that. Holy, okay. Welcome, good morning. Sorry I didn't say good morning to all of you. I'll start picking on you all now. I'll see I think that's everybody. Okay, so we got this far. We're on page 20. Good morning. There we go. The second thing I do is I look at that, and these two, for what we're doing, are always going to match. If those two, if it's not I's or R's or whatever, if they're not the same, come ask me because it's messed up. They should be the same. I think there's some examples in the textbook where they're not, but I don't need to do that. So Michelle, what does the I stand for? No, you're on mute, but I can. All right.
Integer.
Integer. So that means we can have positive or negative, but they're whole numbers. What you need to know, and for this inequality, it means you're going to do dots. So everywhere the lines intersect, you're going to put a dot, and any quadrant is fine. Remember, your quadrants go 1, 2, 3, 4. If you have whole numbers, it's only in here. If you have natural numbers, it's only in there. But integers can be anywhere. Same thing with real numbers. So I don't need those right away, but it makes me happy. The next thing we're going to do, is do the chart. And we're going to make one change to it. Sammy, do you remember what that change is?
I'm not sure. I don't know.
Anybody remember from yesterday? Miranda, how about you?
I can't remember.
Okay, I was about to say I'll settle for a good morning. That'll work too. All right, everybody.
Well, good morning.
There we go. What we need to do to make our lives easier is to change that inequality, so the less than or equal to sign, to just a plain old equal sign. Life is so much simpler. And now we're going to do the graph. So I'm going to pause the video, you know, like 0, and then you put 2 times 0. That stuff, you're going to do that. So you pick whatever number you want for X. I'm lazy, I usually use 0, 1, 2. And then you put it in where the X is, and you're gonna solve for Y. So 2 times 0 is 0, is equal to Y plus 5. And now I need to move this to the other side. Shadow, how do I get rid of that plus 5?
E minus 5?
Nice. So minus 5 is equal to Y. There's my first point. We always do 3 points. So 2 times 1 is equal to Y plus 5. Jose, what's 2 times 1?
15. Oh, I'm just kidding. It's 2.
Thank you. That moment, and you did that nicely in deadpan. It was just that, I don't even know where to go with this. Nice. So 2 is equal to Y plus 5. Okay, keep going. How do I get rid of this 5?
Minus it.
Yep, so minus 5 here, minus 5 there. So what? Still, no, come back, Jose. What's 2 minus 5?
3.
So close. Use your calculator.
2 minus 5. Like 2 take away 5?
Yes.
That's 3, isn't it?
No, you have $2 and you spend 5. You are short 3. It is negative 3.
Oh.
No worries. We're getting there. All right, next number. I'm going to use 2. Whoops. All right, Rena, let's hear from you. What's 2 times 2?
4.
Okay, is equal to Y plus 5. Now what?
Negative 5 on each side.
Nice. So what's 4 minus 5?
Negative 1.
Nice. The cool thing, it's good and it's bad, that once you figure out kind of how to do the first question, they all run the same way, which is great, unless you mess up the first one, in which case sometimes you'll mess them all up. Just saying, so be careful. So minus 1. And now I'm going to plot them. So 0 and minus 5. All right, you know what? I'm going to pause. You're going to plot. Please, please, please go ahead and do that. My first coordinate, whoopsies, can't see it, is 0 and minus 5. So that's 0 on my x-axis and 0's in the middle. So minus 5 down. When you guys are doing your take-home exam, if you really, really hate these little graph things that are pre-done, I can give you some that are bigger because I realize, or maybe it's just my eyes, the numbers are pretty small in there. It's kind of annoying. Now I'm going to go 1 over and minus 3. So that's down there. So basically, if you connected the 1 and the minus 3, there we go. And then we got 2 and minus 1. And I can tell already that's a nice straight line because my brain goes, hey, look, 1 over, 2 up, 1 over, 2 up. That's a pattern, and that's a good thing. Come on. Okay. And I made those dots way too big. That's silly. 1 over, 2 up. My drawing's a little off. Okay, so put arrows on the ends of the line. When you're doing your exam, use a ruler or a straight edge. The edge of a box of Kraft Dinner will work just fine. We can, I don't think we have to worry about labeling the equation. We're only doing one on this page. Oh, and it was a solid line because up here, we said it was going to be a solid line with the less than or equal to. Now, one side is are possible solutions and one side is not. One side is going to be right and one side is going to be wrong. So we need to do our checkpoints. And there's always going to be two that you do. The first one, and this messes people up. You just pick a point anywhere on the graph except on the line. Cleveland, give me the coordinates of some point on that graph. I don't care what ones.
What did you say? Sorry.
I need some coordinates from here. Pick a point for me.
0 and -5.
Unless it's on the line, and you just pick one that's on the line. Here, I'm going to help you. This is my favorite. I'm lazy, and it makes the math really easy. So one of my checkpoints I'm going to use is 0, 0. Because what we're doing is we're checking to see whether the solution to the inequality, or what's called the feasible region, is on this side or it's on this side of the line. Now I take my checkpoint and I'm going to put it in the equation. I was going to say, who am I going to pick on? But I'll just tell you the first time. 2x less than or equal to y plus 5. The key, that comes back. We get rid of it to do our line, but when we're doing the checkpoints, you need that inequality again. Otherwise, it's not going to work. So now we put our numbers in. So 0 goes there and 0 goes there. And that's one of the reasons I picked 0 and 0 is I don't really have to pay attention where I put them because they're the same. So 2 times 0 is less than or equal to 0 plus 5. Ayla, what's 2 times 0?
0.
Yes. Now don't disappear. You're fast. Okay, what's 0 plus 5, Ayla?
5.
Yes. Okay, so this says 0 is less than or equal to 5. Is that right or wrong?
Unsure.
Okay, I'll give you my easy answer, which is the, I gotta go this way, make it match. Nope, was this, never mind, it's too confusing. The open part opens towards the bigger number. So this is actually right. This is the greedy alligator and he's gonna eat 5 fish instead of 0 fish. So I'm gonna put a big old check mark on this side because that's probably, I'm pretty sure that's gonna be my solution set. But I'm a very paranoid mathematician and you need to be too, and you wanna get full marks. So we need to pick another point. Now this one matters. It needs to be on the other side of the line. Michelle, can you give me a number on the other side? So somewhere in this area.
On the top?
Oh, that part we're okay. So it's somewhere to the right of the line or below the line.
Okay, 4 and -4.
All right, cool. So she picked that one. That's a lovely choice. As long as she was underneath the line, that's all that matters. And then we do it again. 2x less than or equal to y plus 5. Give you a minute to try that one out. This time you have to be a little more careful because the numbers aren't the same. I'm going to actually just draw arrows to remind myself, right? The x coordinate's always first, then the y. So 2 times 4 is less than or equal to minus 4 plus 5. 2 times 4 is 8, less than or equal to 1.
No.
No. And that's good. It's the only math question I know where you get it wrong and you're like, woohoo! It's awesome. So we know that this side, is that for you? This side is the solution side. Grab the pen that you can see better. So the only thing we have left to do is to show the feasible region. And that part is this integer thing. So we're going to do dots, and it's going to be in any quadrant. So you can use your pen, your highlighter. I'm hoping this will show up for us. And you start dotting. Now,
Do I have to honestly dot all of them?
no, Lord, no.
Oh,
And yes, you were not. All right, so draw some dots. Now, to get it right, what I'd be looking for is I want to see some dots on your line. Because the inequality is less than or equal to, we need to make sure that we include stuff on the line. I would consider that good enough. You are showing me that, first of all, it's dots, which is integers. You're showing me that those answers are in the first, second, third, and fourth quadrant. But you don't have to hit every single dot because that's just silly. So that would be a fine solution. If you have time to do all those dots, you could maybe spend it better. Phone a friend, tell me you love them, pet your cat, I don't know. But, you know, it's also not bad therapy. Just make lots of dots. And ta-da, there it is. Any questions? Oh, put it back where it was. You guys can see. No, no one's yelling at me. Okay, cool, cool. Let's turn the page. Ah, sorry. That's a moment of, wow, look at that marker just sink right through that page for me. I'm an idiot. And I recorded that. That is so cool. In this section, there's going to be word problems. If you were perusing your exam, I think there's at least one word problem. In this section, there's some in stats. So we're going to do one this morning, and then we'll do some more together as practice. If you look, by the way, next page. Oh, no. 22 is another one. 23 is page 23 is a bunch of practices. So here we go, word problem, or sorry, it's supposed to be an application. I'm not supposed to call it a problem because that might scare students. A cell phone producer distributes boxes of units to retail stores. A unit is either a cell phone or an accessory, and each box can have up to 24 units. If each box must have at least one phone and one accessory in it, what are the possible combinations in the box? Okay. So I got a box. How many things can go in the box? Anybody?
24.
24. I was like, don't overthink this. 24 units, 24 things. Use units. Okay, so if each box must have at least one phone. So let's say we have put one phone. And how many accessories could I put in there if I put one phone? Anybody?
23.
I have 23. And that fits everything. We need at least one phone and one accessory. So what if I put in 10 phones? Clarissa, how many accessories could I add? You have 24 altogether and 10 of them are used up. Clarissa, how many are left?
14.
Perfect. Now I have one. So you get that. Oh, what if I had one accessory? And I would need, okay, I'm not going to ask you, it's 23 phones. Because this question very specifically says it needs at least one of each. You're going to get really good at reading. Not more than, not less than, has to have at least one. This is giving us a really good hint of what our solution set's going to look like. What if I put in my little box 10 phones and 10 accessories? I would like you, give me a thumbs up if you think that's okay. I got one. You can give me electronic. There, we got some electronic ones. Oh, you guys are awesome. We have more people over here and more people over. And stare at this side for a while. Okay. Because what's the key? Each box can have up to 24 units. So this is another hint. That's going to tell us about our inequality. So less is fine. You have to have at least one of each. So literally they could send a box that had one phone and one accessory, and that would be okay. So I'm trying to figure out the easiest way to do this. Well, let's try it. So here's our steps. First thing, assign variable. Sometimes, if the questions are a little more complicated, I would start by make one of them A for accessories and C or P for phones, but there's not much going on in this one, so we'll just go easy. So we'll let X equal the number of phones and Y equal the number of accessories. Those two things, you could have up to 24. And I think you're already telling me. So X plus Y, so my phones plus my accessories. Now, if it was exactly 24, I'd have a lovely equation like that. But it says it can have up to 24. So that's not quite right. It's going to be a less than or equal to. That means the sum of these two, phones and accessories, is always less than or equal to 24. Or in my brain, 24 is always bigger than this one. And there's our equation that we need. All right. Since I have completely messed this up, I want you to do this. And I'm going to find, so do the table, and I'm going to find some graph paper somewhere. So I'm going to pause that and let you guys do it. Oops. Okay, sorry for those of you that are following along in the recording. We discovered pretty quick that, yeah, my graph isn't big enough. So I just doubled the numbers on each of the axes to make it work. And then I chose 10, and I'm going to use 12. So 12 plus y is equal to 24. And it does not matter if you choose the same numbers as me. If your math works out, it's still going to give you the same line. And I'm just going to finish, well, let's do 14. So 14 plus y is 24. So y is going to be 10. All right, so 12 and 12, 12 over, 12 up. And 14 and 10, 14 over and 10 up. And those look like in a nice straight line. Oh, wait a minute. We did have our inequality figured out on the other page. I just paused because I was like, well, did we talk about how to get the right line? And we did. We go back to here. We said it was a less than or equal to. So this part means it's a solid line. How about you guys give me a thumbs up when you're caught up with me? Okay. Awesome. Cool. If you know what the next steps are, go ahead and get started on them. All right, so the next thing we need to do is figure out which side. We've got this beautiful line in here. We need to figure out which side of that is the solution. So we need to do our checkpoints. And I think I'm going to pause and I'm going to let you guys do your checkpoints. All right, back at it. All right, checkpoint.
Put it back.
Gonna do that. I'm gonna use 0, 0 like I always do. And we have to go back, sorry, keep flipping, to the original inequality that we created. So we need the less than or equal to sign again. So x plus y is less than or equal to,
Don't push buttons.
So we're going to put the zeros in. So 0 plus 0 is less than or equal to 24. 0 is less than or equal to 24. That was easy. And that is correct. So that point is right. Now, always 2 checkpoints. Dominique, I have not heard from you this morning. Can you give me a suggestion, excuse me, for a point that I can use for my second checkpoint?
Does it have to be on the other side or?
Yes, it does.
So which?
So this side is, we've already done, so I need a coordinate of something up there.
16 and 14.
16, perfect. There it is. My camera didn't help much. Yes, so 16 and 14. All right, so here we go again. X plus Y is less than or equal to 24. Oopsies. Now I put my numbers in. Sorry, 16 plus 14 is less than or equal to 24. And I think that's 30. Yeah. So this is the no side, this is the yes side. That's pretty cool. That's good. When they both work out, if you draw your line and you do this and they're both yes or both no, either your checkpoint math is messed up, you're reading the coordinates, or occasionally it happens that you haven't graphed the line properly. I've seen students do that and I've spent like, I'm looking, they're like, what's wrong? Why isn't this working? And it's just like, I don't know. And finally we figured out they plotted the line wrong. If you get in that situation and you've got an error, you know it's wrong. Sometimes just get a new piece of paper, redo the entire question, not looking at the old one. Because sometimes trying to find the error is really, really difficult and you won't find it until you redo it. Okay, so that's good. We still have to finish. We got to figure out the R-win, which is how I'm going to shade it. And we're going to go back to our original question. Okay. So remember, those are our choices when it comes to shading. We have real numbers, we have whole numbers, integers, and natural. Okay, that didn't look nice, nearly as nice as I hoped it would. And to make this decision, you have to go back to the original question, figure out what you were talking about. We have boxes which have cell phones and accessories. So the first thing I want to talk about is real numbers. Real numbers include fractions. So are you going to have a box with half a cell phone? No. So this is not it. That's usually what I do. Or a negative cell phone. That doesn't make any sense. So that's no good. And you know what? I can also throw out integers because those include negative numbers. And I can't send minus 4 accessories. So we're either at whole numbers or natural numbers. And the truth be told, almost every question where it's like a word problem, you know, how many of this and how many of that can we send or something like that, it's almost always going to be whole numbers or naturals because negatives don't make sense for the most part in the real world. Whole numbers include 0. Natural numbers start at 1. Which one? How many? Okay, let's do a quick survey here. How many people are thumbs up for whole numbers? think that's our solution set. 1, 2, 3, 4. Oh, let me
I
see.
show a thumbs up, but I can't find it.
Okay, 5. I get more people? I do this? Sorry, I'm messing with the screen again. Oh, you know that, right? Sorry. Where's everybody else? Is there more people? I hate to say it, but you're all wrong. I was going to do integers, and I was going to do, I have no clue, but we'll make it fast because it says each box must have at least one cell phone and one accessory. So there has to be one of each. So 0 is not an option. So after all that work, it's natural numbers. And natural numbers means you're going to dot and you're going to be in the first quadrant. So only positive numbers and no zeros. You may not appreciate this point at that. Try it again. It's a good thing that your exam is open book. Wouldn't that be nice? Because you have all those nice charts and you'll have all these examples worked out. You don't have to memorize some of this stuff. All right, so I'm going to start dotting. It's going to be in the first quadrant. So this is all I'm allowed to use because I have to have positive numbers, and this is the only area that is positive. And I can't, oops, don't do that. I can't be on the axis, so there's no zeros. I'm just gonna be done with that. So if you feel like putting dots in everywhere you can, if you don't, that's just tickety-boo. The last step, which we didn't have to do before, but it's here, so I'll make that go away, says check if it's reasonable by going back to the original question. So let's pick a spot. Let's pick this dot. And I just randomly picked one in there. Who have I not talked to in a bit? Clarissa, what are the coordinates of that point that I just circled?
2 and 10.
It is 10 over. How many up?
2.
Yeah. Okay. If we go back, I know I'm flipping the papers way too much here. Okay, we'll do it this way. Get everybody on, get all the stuff I need on screen. We said when we started that X was our number of phones. So this represents 10 phones. And the Y is the accessories. And that's why it's kind of important to label that stuff when you start. Okay, so the question says, each box can have up to 24 units, and each box must have at least one phone and one accessory in it. So if I have 10 phones and 2 accessories, do I have a box containing up to 24 units? Thumbs up, right? It's under 24, which I'm supposed to have, and it has one of each. So that's what I mean at the end by going back. So you just basically pick a point in there and see if based on that, the word problem works. This is not fun stuff to teach online. You can watch the videos. if it'll help you to watch them again, but you can. I'm going to save. If you feel like doing page 22 about good old Mrs. Nicholson and her cantaloupe honeydew salad for the banquet, you go right ahead. But you might not want to do that. We'll tackle it tomorrow. Okay, or try it and watch the video, either one. But it is slightly different than the one we just did. Okay, and these ones, it's up to you if you want to do the practice. I would probably hold off on it. The equations that you need for these questions are in the back. All right, that is enough of that. I want to do some review. Your exam is due on the 11th, so you've got over a week to do it. And there's the multiple choice, there's the written part. If you're thinking, I can't possibly get through this, I'd suggest you do like one section a day. And I would probably leave that first section that's all, well, the multiple choice you can do, but the section on this stuff, you might want to leave. Okay, so I'm going to start on chapter 2, which is the angles and stuff like that. You could start there doing that tonight, or maybe you have a favorite section. I dig trigonometry and I rock that stuff. So that's what I'm going to do first. Anyway, so angles and stuff like that. I'm going to start with the polygons. So I've got a 1, 2, 3, 4, 5, 6, 7-sided figure. I would like you to find the sum of the interior angles. I don't care how you do it. Well, don't Google it. Do some work. There's 2 ways you can do it. 3. If you want to use the formula, go for it.
Joanne,
Hello.
did you say math was open book?
Yep.
And that other exam from yesterday?
The one that's was in your mailbox? Is
Yeah.
that what you're talking about? Yeah, that's open book.
Is that the math one or?
Has it got your name written in blue pen on the front of it?
Yeah.
Yep. That is your math final.
Well, I didn't have a look at it actually.
Okay. But yeah, it's your math final and it's open book. So
All right.
you can use your notes, you can use the videos, you can use any of that stuff. So expect good things from everybody. Cleveland, where did you go? You on a different screen. Okay, so 2 ways to do this. 3 ways. I'll do two easy ways. If you have the picture drawn for you, you can, oh goodness, you can always just divide it up into triangles. And that gives me 1, 2, 3, 4, 5 triangles. Ayla, what is the sum of the angles inside one triangle? If you added all three of those angles up, what do they add up to?
Like which ones?
Okay, so if I just drew a triangle here, I'll make sure I'm on the screen, and I wanted you to tell me if you added up this one and that one, how many degrees does that equal up to?
I don't know.
Rena, help her out.
180.
Thank you, Jose. Times 180. I think it's 900. All right, so it's 900 degrees. That's one question. That's actually pretty much as we can do on this one. So that to me is the easiest way to do the question. You might also just remember, and this is what we did in class a lot, if there's 7 sides, it means there's 5 triangles, and then you just continue on that. So if you don't have the picture and it's like a 17-sided figure or something, it's probably easier just to realize there's always 2 less triangles. And then there is a formula and you can look it up, but I don't remember what it is. And it's not hugely important. If I drew, so this is a polygon, which means it's got straight sides and it's closed up. If I were to say a regular polygon, nope. Try that again. What do we know about that? Anybody?
All the sides and angles are the same.
Beautiful. That is exactly what it is. So, all right, I'm going to try and draw a regular hexagon. And it's not going to be great. Kinda. I'm going to cheat. I'm going to do this. There. I can't draw, but I can geometry.
Ah,
Can you find me the sum of, now that we've done it once, I would like you to find the sum of the interior angles. That one's getting better, getting closer. All right, so I'm going to divide it up because that's just easiest. 2, 3, 1, 2, 3, 4. So 4 triangles is equal to 4 times 180. Is 720 degrees. But with this question, I can ask some other ones. So that means if I take every one of these angles, I'll draw this because it's better, and add them up, all of those add up to 720. when it's a regular polygon, I can extend the question and ask you about what one triangle is. So now I want you to figure out how big just one of them is. Miranda, what am I going to do?
But didn't you just divide it by 4 or no?
Oh, well, if I divide it by 4, I'm going to get back to 180.
Oh,
No.
yeah.
Great. How many angles are there?
6. Oh,
Yes,
divide by 6. There we go.
there we go. If you accidentally do it and you get back to 180, oops. 720 divided by 6 is 120 degrees each. So be careful on the question. Does it ask for all of the angles or does it ask for just one angle? Just saying. Watch for that. Okay. And we could even do, if we want to look at this angle out here. Now these ones were interior angles. So this one, Dominique, what would we call it? If this is interior, what's the ones out here?
Exterior?
Nice. So how in the world do we do that? Well, it's real simple. This, right? It's going to look any better if I do it in green. That forms an angle right there. It's a nice line, which is, Brianna, how many degrees in a straight line?
What'd you say?
How many degrees in a straight line? So from here to here, how many degrees is that?
90.
Almost. Double it.
180.
180.
Yeah, I heard that. You got weird echoing in your place. 180 degrees. We're 180 degrees. And we used up on the inside 120 degrees, which leaves us 60 degrees. So each one of these angles on the outside are 60. You could have cheated on that question. The sum of the exterior angles on anything is 360. So if you go 360 divided by 6, you'll get 60. Different way to do it. Okay, so triangles, polygons, all that. Done. Did I do that right? I did that right. Okay. First of all, what's, whose turn is it now? Rachel, what's with these extra arrowheads? What do they mean? What does that tell me about these two lines? Sammy, help her out.
They're parallel.
You betcha. So double arrow here, that means these two lines are parallel. They look like it anyway. And I also put some here. So everything is parallel. When lines are parallel, it's way more interesting. So let's make this over there 150 degrees. And now, if you can, find all the other angles. See how many you can do and see if you can remember why they are the number you pick. All right. I thought I'd paused the camera and I forgot. Oops. Let's start over here. So you guys can see better. I'm going to go down the list. Jose, what is angle A? What's the measure of angle A?
Angle A?
Yep. Okay, this much
Was it
is 180. And we already used up 150. How much is left over? So it's 180 minus 150.
30?
Yep. And the reason there would be supplemental angles. All right, Miranda, what's angle B?
150,
Why?
because it's vertical.
Vertical angle. Excellent. All right, Dominique, what's angle C?
30.
Why?
I don't know.
Okay. Driana, do you know why?
No.
Okay. Well, two choices for answers. You could either say it's vertical to A because it's crisscross and it's the same. Or you could say, you know what? It's supplemental just like this one was over here. Either one. Okay, so vertical angles are always equal. Supplementals always add up to 180. And now I'm not going to do all of these. I'm going to skip up to here. So angle H. Rachel, how big is angle H?
Uh, 180.
Oh, close. It's 150. 180 would be a straight line.
Oh.
But that's the truth on these. Like, look to see if it looks the same size. Odds are often quite it often is. But why? Samantha, besides the fact it looks the same.
It's 30%. Or, oh, sorry. Why is it's corresponding?
Yes, corresponding. And I just realized, you know what? We can talk
All
about, yeah, this one's 30, that's corresponding, and this is 30, it's corresponding.
150
And this
because
is
that's
150.
vertical.
No, heck fire. I'm just going to keep using corresponding. It's a lovely choice. And then we could, oh yeah, the rest of it's boring.
Yeah, it's all 150 and 30.
Yeah, I shouldn't have made them all parallel. Okay, gonna make a simpler one. Doo-doo. So there are some questions that on your exam. Those are parallel, work with me. Where we start to use equations. Oh, let me at least make it sort of interesting. Excuse me. With these ones, it's kind of like two choices. Either they're the same or they add up to 150 or 180. That's pretty much all your choices. Ayla, do these angles look like the same size or different size? Michelle, same or different?
They look the same.
Okay, so then it's simply 2x is equal to 50. Michelle, keep going, solve it for me.
20, it would be 25.
Divide each side by 2. X is equal to 25, and ta-da, there you go. I mean, that was super simple. What if I said this was okay, that's 5y and that's 150. Clarissa, does the 5y angle and the 150 angle, are they the same size?
Yeah.
Okay, my drawing's bad. To me, this one's smaller, right? They're side by side. So Clarissa, what can you tell me about two angles that are side by side? What do they add up to?
180.
Nice. So in this case, you would go 5y plus 150 is equal to 180 degrees. And then you'd solve that. So I'll give you guys a chance to solve it.
Y equals 6.
Are you sure?
Think so. I don't know.
I don't know. That's what I figured out in my head, but I don't trust it. So subtract 150 from both sides. 5y is 30, add 6. So you're going to have to really pay attention what the question is asking. and where everything is located. Do one more.
Don't.
I have no idea. See if you guys can solve that. I don't know if it works. Not sure if you're going to get a whole number out of that. Shadow, what can you tell me about those angles?
Maya, what are you doing?
Yeah, I don't know.
How much do they add up to?
180?
Yep. There we go. Yeah. Solve that. Yeah, it's not going to be a whole number. It's not going to be pretty, but it works. You know? Harmony, what did you get?
Maya.
I got 14.
Okay, maybe it did work out better than I thought. So 7x and 3x is going to be 10x plus 47. I'm going to put these two together is 180. Now I want to get rid of this. So I'm going to subtract 47. There it is. 180 minus 47 is 133. So divide by 10, is equal to 13.3. That wouldn't round to 14.
I forgot a 7.
Oh, okay. So I'm like, how did you get a whole number? That seemed just so weird. Cool. And then depending on what the question says, it might just say solve for x, but it probably says find the angles. So then you would just take this one and you go 7 times 13.3. And here you'd go 3 times 13.3 plus 7. And then solve those out. Ah, sorry, bracket in the wrong spot. That, wrong page, is it for today. So, does anybody have any specific questions? So yesterday you got your mail and your exam at the end of the day. See, there's a few kicking around in mailboxes. Yeah.
I got a weird email, and it was from Brian, and it's like, Samantha Kinniquan student summary, but it won't let me open it, and I don't know what that means.
Did anybody else get an email from Brian and a summary and it didn't open?
Yeah, it's regarding your marks and stuff.
Did you open yours though?
Yep.
I can open mine.
Well, you know what? It's just printed off ThinkWave. I don't know what's in the email because, he didn't send me one. But that's what it is. It's just your marks from ThinkWave. So it's
Oh.
good. All right, anything else? We're good? Who's gonna be in class tomorrow? One.
Just me. Just kidding.
All right, I want to see you in class. Perfect. In class, 9 o'clock. And stay busy right now. Stay focused. You can get this stuff done. All right, we're out of here as soon as I figure out how to do this.